Hello student, welcome once again to my YouTube chemistry channel, Amazing Chemistry Classes. So today I have come up with this video of organic chemistry in which I have started up with optical isomerism, very important topic for organic chemistry. So before starting my video, just one request to all of you that do subscribe my channel and share my videos to all those students who are unable or who cannot afford uh, expensive coachings and tuitions. So it is my humble request to all of you that do spread my videos. There is no intention, bad intention behind this statement. Just only thing is that I really want to help those students who cannot afford expensive coachings and tuitions. So these videos are actually have been made by me for those students, those who really want to study, those who really want to gain knowledge of chemistry. As I always said, in case any student who is facing some problem of class 9, 10th, 11th, 12th in chemistry subject, you guys can write down on comment section or you guys can contact me also. So I'm always there for you बच्चों, जो भी आपको किसी भी तरह की कुछ हेल्प चाहिए in terms of study material, in terms of books, you guys can contact me anytime. I'm there for you. So let's start today's video. So first is, what is optical isomers? Let me read out the definition. The optical isomers क्या होते हैं? Basically first we need to understand what is chiral carbon. So chiral carbon is one which is having as we all know, carbon की क्या होती है? 4 valencies होती है. So all the 4 valencies has to be satisfied with the different groups, 4 different groups. That is known as chiral carbon. And as far as optical isomers are concerned, the isomers that rotate the plane polarized light are called optical isomers. So optical isomers that are mirror images that are non-superimposable are called enantiomers. ये मैंने last video में भी discuss किया था regarding enantiomers and diastereomers. So in continuation with this, here the given definition of enantiomers are those optical isomers that are mirror images but are not non-superimposable, and the molecule or ions that exist as a pair of enantiomer is said to be optically active and are said to exhibit optical isomerism. Here you can see I have shown an example of stereoisomers. Like if we show your hand, left hand, so there will be a mirror image and you can superimpose on it. Okay, similarly a mirror structure, here you can see I have shown a molecule cobalt with 5 different ligands, so it is also a mirror image of each other. So now talking about enantiomers, it is one of the 2 stereoisomers that are mirror images of each other but are non-superimposable. They are known as enantiomers, that is R lactic acid and S lactic acid. This is also this all discussion I have done in my previous video also. Similarly diastereomers, here you can see stereoisomers that are non-mirror images and non-superimposable. The example is D3Os and D-rithros. Now talking about the reaction mechanism, this homolytic fusion, heterolytic fusion already I discussed in my previous video, so I'm not going to discuss in detail. Then covalent bonding, homolysis, bond fission, these all topics I have already covered up in my previous video. Homolytic fusion and heterolytic fusion already I discussed. All right. So now talking about electrophiles, what are electrophilic reagents? Electrophilic reagents are those which are electron loving species. Philic means electron loving. Okay, so these are electron deficient species and they attack the site of high electron density in the substrate, and they may be positively charged ions or neutral molecules. Electrophilic means, बच्चों सिंपल सी बात है, मैं हमेशा बोलता हूँ कि those ions which are oppositely charged they always attract each other. तो because they are electron loving होगा तो itself वो कैसे होते हैं? Positively charged. So they are known as cations. Positively charged are known as carbocations and negatively charged ions are known as anions, carbon ions, and they possess an atom with incomplete octet. Now talking about electrophilic reagents, they are Lewis acid. They can accept an electron pair from the substrate to form a covalent bond. Here I have given few examples of electrophilic reagents like proton ions, nitronium ion, boron trifluoride, aluminum chloride. Now talking about nucleophilic reagents, they are nucleus loving species. They are electron rich species, okay, and they attack the site of low electron density in the substrate. They may be negatively charged ions or neutral molecules. and these possesses an atom with a lone pair of electrons. So nucleophilic reagents, I have given examples like hydroxy and cyanide, all the negatively charged. Like if I talk about halogens like chlorofluorobromo, we all know that these are electronegative atoms, and they are possessing a lone pair of electron. That is why they are considered as a nucleophilic reagents. Here few examples like water molecules, as you can see, lone pair of electron over the oxygen atom. Similarly ammonia, if we talk about, on nitrogen there is a lone pair of electron. That is why they are considered as a nucleophilic. Nucleophilic means nucleus loving itself. They are negatively charged, they are having the lone pair of electrons. Now talking about reaction intermediates, first one is carbocations. Already discussed, these are the carbon atoms which are having the positive charge. They are electron deficient species, and these are actually sp2 hybridized. Okay, and as far as shape is concerned, they are having triangular planar shape. Now talking about carbonium and carbocation, the stability part, this already I discussed in my previous video regarding the tertiary is more stable than your secondary, and secondary is more stable than your primary, and then methyl. And the next point I'm going to discuss, that is it can accept electron pair from a nucleophile to form a covalent bond, and these are Lewis acid. Because what are Lewis acids? Lewis acids are those acids which can accept the electron pair. Here example is tertiary butyl carbocation. Okay, this is basically, in this video I have discussed all the topics which I already covered up in my last video. So this is kind of a revision. Here the general stability of order of carbocation, I have written over here, tricyclopropyl carbocation is more stable than your dicyclopropyl carbocation, and further it is more stable than your tropylium ion. Then it is more stable to triphenyl carbocation followed by diphenyl. So this is the stability order. You guys can take a snapshot. आइए बच्चों, आप लोगों को लर्न करना है. दिस इज सेल्फ एक्सप्लेनेटरी स्लाइड. आई एम नॉट गोइंग इन डिटेल regarding the stability. This is just you have to mug up and you have to learn. Now similarly talking about carbon ion, as the name itself self-explanatory, that the carbon atom which are negatively charged ions are known as carbon ions. They are electron rich species, and the carbon atom possesses 8 electrons in its outermost shell. Okay, so these are sp3 hybridized, and it carries a lone pair of electron. Its shape is pyramidal. So carbon ions are Lewis based because they contain a lone pair of electron. Here the example I have given is methyl carbon ion. You guys can see the stability of the methylium ion. Methyl carbon ion is more stable than your ethyl, followed by a secondary or isopropyl, and the least one is tertiary butyl carbon ion. This is the stability order. Here you can see triple bond is more stable in terms of stability. Triple bond with lone pair of electron is more stable than your double bond, and least one is your sp3 hybridized with lone pair or the anion. Okay, with a negatively charged ion. So single bond, that is sp3 hybridized carbon with negative charge, is least stable, and the triple bond with negatively charged is more stable. Here it is given over here the stability order also. Triphenyl is more stable than your diphenyl, and benzyl is the least stable in terms of stability of the anions are concerned, aromatic anions if we consider. Similarly, allyl and benzyl carbon ions through primary are more stable than your simple primary alkyl carbon ion due to the resonance. So here few examples are given. The derivatives of anisole and nitro derivative of, so we can compare in both the cases. Like if I talk about anions, here you can see the difference between the two is, although all the three are carbon ions, the only difference is the substituent group, on which first is OCH3, which is having a positive I effect, due to which there will be electron density over the carbon ring. Whereas if we talk about nitro group is concerned, as we all know, nitro group is electron withdrawing group, so there will be scarcity of electron pair over the benzene ring. Accordingly the stability order varies. Now carbon free radicals, so these are the species which are having trivalent carbon and it at the atom bearing no charge and having odd electron or unpaired electron. These are known as free radicals. Okay, the free radicals are highly reactive species due to the presence of odd or unpaired electrons. As we all know, those ions which are having unpaired electrons, so they are always having a tendency to react easily. That is why they are known as highly reactive species. And these free radicals are electron deficient species, hence considered to be a neutral electrophiles also. Okay, in methyl free radicals, carbon undergo sp2 hybridization. Here you can see the stability order of a free radicals. Triphenyl methyl is the most stable, then your benzyl, followed by allyl, then your tertiary, secondary, primary. Methyl and vinyl is the least stable free radical. Now talking about carbenes. So what are carbenes? Carbenes, the singlet carbene has two non-bonding electrons and are paired, and these are present in the same orbital, that is sp2 hybridized. Okay, and it is planar and angular. Triplet carbon has two non-bonding electron in different orbitals, whereas in triplet carbenes it is called also known as biradical or bivalent free radicals. Triplet carbene is sp hybridized and its shape is angular. Here you guys can see the difference between the two structures of singlet and triplet carbene. In general, a triplet carbene is relatively more stable than your singlet carbene. Now talking about few more topics, that is electron displacement effects. Here you can see inductive effect. Already I discussed in my previous video also that what are inductive effect, how the electron get displaced. So it involves basically the displacement of electron in a single covalent bond, that is sigma electrons are involved. So what it is, let me read out the definition for the inductive effect. These are the permanent polarization of single covalent bond due to the displacement of electron towards the more electronegative atom due to the difference in electronegativity. Very important, self-explanatory. Let me define in more easy form. जैसे कि हम लोग जानते हैं बेटा, कोई भी कार्बन के साथ जब हेलोजन ग्रुप लगा होता है, so all halogens are more electronegative than your respective carbon group, so there will be always a tendency of attraction of electron. Okay, so what happen, there are groups which are either absorbing or withdrawing the electron pair toward itself, or there are certain groups which actually push, which actually does not attract the electron although they push the electron. So this is the difference between them. Yes, here on this slide, sorry, in between the slides get deflected. So what I was talking about, that is the inductive effect, that there are certain groups which actually absorb the electron or which actually attracts the electron, and there are certain groups which actually opposes, that is which pushes the electron. So and it is a permanent effect. Okay, now talking about the reaction mechanism, here you can see inductive effect decreases with distance, operates over a shorter distance. Here I have given an example of 3 carbon where it is attached with the chloro group. So the maximum attraction will be on the first carbon, then on the second carbon, and third one is having the least. So here you can see there are certain groups which shows the positive I effect, that is the electron releasing group, that is your ethyl group, then isopropyl group, then methyl group, and there are certain groups which shows negative I effect, that is electron withdrawing. So in electron withdrawing, the groups are cyano, nitro, halogens, carboxylic acid, hydroxy, and amine. So what are the application of inductive effect? It explains the stability of carbonium ion free radicals, acidic nature of carboxylic acid, and basic nature of amines. The decreasing order of the plus I effect, here you can see, this is a very important slide, bacho. You guys can take a snapshot and try to learn. It will help you to solve the problems in your competitive exams also. So this is what I'm not going to discuss in detail, just that you have to learn these groups and their order of reactivity. Some examples of plus I, that is positive inductive effect, and there are certain groups which are having the negative I effect. and the order of reactivity is given over here. Now talking about electromeric effect, it explains the displacement of electron in multiple bond, that is in double bond or triple bond. The complete transfer of a pair of electron towards one of the atoms in presence of attacking reagent is known as electromeric effect, and it is a temporary effect. Its effect operates over a long distance. Here I have given an example of ethene. You can see there is a partial transfer of electron from the pi bond. So what happened, there is a positive charge on the left carbon and a negative charge generates over the right hand side carbon. So what is the difference between inductive effect and electromeric effect? Inductive effect is a permanent effect, however electromeric effect is a temporary effect, and inductive effect is due to the presence of electronegative atom. As I have shown, the carbon attached with the halogen group, so there will be always a tendency of gain of electron towards the electronegative atom. However, in case of electromagnetic effect, it is due to the approach of attacking reagents. Okay, next point is, it is in inductive effect, it is the mobility of electrons along the carbon-carbon sigma bond, whereas in electromagnetic effect it is due to the mobility of electron in a multiple bond, that is in double or triple bond. Inductive effect is due to the mobility of sigma electrons, whereas electromagnetic effect is due to the pi electrons. This effect becomes negligible after second and third carbon in the chain, whereas if we talk about electromagnetic effect, this effect can be relayed through a longer distance in the chain due to the conjugation of a double bond. So in case of inductive effect, the displaced electron does not leave its valence shell, whereas in electromagnetic effect, the displaced electron pair leaves its the valence shell. So these are four more differences, that is, it is represented by I, however electromagnetic effect is represented by E. This involves, what is that, inductive effect involves the partial transfer of sigma electron, whereas electromagnetic effect involves the transfer of pi electrons. Okay, next difference is, it is the effect which is partial charge are developed on the atoms, whereas in electromagnetic effect there is a complete charge formation, that is plus and minus. As I have shown, in case of ethene there is a transfer of electron because from the pi bond electron pair gets shifted on the right hand side carbon, so there is a formation of complete charges, that is positive and negative. So already discussed regarding the homolytic fission, these are symmetrical in nature. And few more question answers MCQs, like in carbocations carbon is sp2 hybridized. These points already I discussed. Inductive effect is a permanent effect. BF3 is electrophile, and nucleophile, as I told you, that it has a lone pair of electron, that is why they are having the tendency to lose the electron. They are considered as Lewis bases. Talking about resonance and hyperconjugation, very important point, that is, what is resonance? The phenomena in which two or more equivalent structures for a compound can be written that involves identical position of atoms but different arrangement of electrons. The best example is of benzene, where the pi electron, or you can see the pi bonds, get altered. So these structures are also called as resonating structure or canonical structures. Here you can see the resonating structures of benzene. So all the three structures are correct, but their representation is different. So these are known as resonating structures, and as far as if we substitute benzene with any group, so with respect to that group the different positions are ortho, meta and para. Now talking about the directive influence of a functional group in monosubstituted benzene, very important point bacho, the group which is present, as I told you, whether it is having plus, it shows plus I effect or negative I effect, and accordingly the substitution will takes place. So when the transfer of electron is away from an atom or substituent group attached to the conjugated system, it is termed as positive resonance effect. Here you can see what happened, a lone pair of electron from the oxygen gets shifted, results in the formation of double bond between oxygen and the benzene ring, and hence there is a transfer of electron from the pi bond and formation of negative, that is a lone pair of electron, you can see. So this is how there is a transfer of electron, results in the formation of different resonating structures. So what I have written over here, that electrophiles, positively charged species which attack on ortho or para position when substitution on benzene is electron donating group. So electron donating group I already discussed, like amine, hydroxy group, analkyl, anacetyl. Okay, so these are all known as electrophile. Now talking about the negative resonance, as I told you, NO2 group is having the tendency to withdraw the electron from the benzene ring. So what happens? There will be a formation of positive charge. So what is the difference between the two? In above you can see in hydroxy, that is in phenol, there is a formation of negative, whereas in nitro group there is a formation of positive, and that is why when there is a substitution on nitrobenzene, the coming group which will attack will always come on the meta position. However, when there is a substitution on phenol, the substituent group will come on the ortho and para position. So this is the difference between the negative and the positive resonance, and the electrophile will attack only on the meta position. Because क्या है यहाँ पे क्या difference है बेटा? Nitro group जो present है हमारा, it withdraws the electron. So there will be formation of positive charge over the benzene ring. However, hydroxy group will push the electron, so there will be increase in the density of electron in the benzene ring. So this is the difference between the two, that is known as, one is positive resonance and second is negative resonance. Here the given examples of electrophile that will attack only on the meta position when substitution on benzene ring will takes place. Examples are nitro, cyano, aldehyde, formyl group, carboxylic acid, sulfonic acid, or ester group. Okay, so there will be the transfer of electron is towards the atom or substituent group attached to the conjugated system, and it is known as negative resonance effect. Now talking about hyperconjugation, very important point for the organic chemistry students need to understand that the delocalization of sigma bonding electron of alpha carbon H bond towards the unsaturation is known as hyperconjugation. बच्चों यहाँ पे आप समझो क्या हो रहा है, when there is a transfer of electron, this bond between carbon and hydrogen, it get transferred. So what happened, the H plus ion, it gets leave, okay, and there is a formation of double bond between carbon and carbon. So this is known as ethyl carbocation. There is a partial positive charge, but what happened when the bond gets shifted, it results in the formation of double bond, and the positive charge which is there on the carbon, it gets terminated, and there will be removal of H plus ion, okay, hence results in the formation of ethene. So this is the resonating structures, and the application of hyperconjugation is, it explains the stability of carbocation, free radicals and alkenes. Guys, take a snapshot and need to understand what actually is going on. Organic chemistry से concepts based होते हैं और कैसे इसमें हम लोग इलेक्ट्रॉन को ट्रांसफर करते हैं, और there is a shift of bond also. Here you can see there what happened, the leaving group is H plus ion and the bond gets shifted, result in the formation of double bond, and positive ions, positive charge over the carbon has been diminished, because what happened, the octet of carbon, both the carbon gets completed with the formation of double bond. So this is the application of hyperconjugation. So now the some MCQs on these topics, that is the delocalization of electron due to the overlap between the p orbital and the sigma bond is called as both hyperconjugation or no bond resonance. Next is electron donating group is both amine and alkyl, both are electron donating group. And electron withdrawing, already told you, like nitro group, carboxylic group, a formyl, that is aldehyde group. And in electrophilic substitution reaction of nitrobenzene, electrophile will attack on the meta position. Okay. Now talking about reagents, electrophilic reagents and nucleophilic